Good day, students. On this clip, we're going to be going over five examples on how to graph transformed absolute value functions. Okay. All right. So let's take a look at number one. It says graph each equation. So we're going to be graphing this function right here. Um, so first thing we want to do is we want to place a function in the general form. The general form for absolute value functions is y minus k equals a x minus h. All right. So just note that the center. To get the center, you take the center or the vertex. I'm sorry, the vertex. To find the vertex, you just take the opposite of the number next to x, which is h, and in the opposite of the number next to y, which is k. So that goes to your vertex. And then for your opening, just note that if a is positive, it opens the absolute value function opens upwards, and then if a is negative, it opens downwards. Okay, so a is also an adjustment factor. It makes it wider or narrower. In this case, we're going to have a equals 1, so there isn't going to be any alteration to the function. Okay, so remember that the absolute value function is like a v. If it opens up, it's like a v going up like this, and then if it opens down, it's like an upside down v. All right, so there you have it. All right, let's take a look at number one. First thing I'll do is I'll place it in vertex in the general form and extract the vertex, okay? So for this problem, we have y equals x plus 3 plus 1. This 1 right here is not in the absolute value, it doesn't affect x, so it affects y. So I'll subtract 1 from both sides. So that yields y minus 1 equals the absolute value of x plus 3. Okay, in this case, a is 1, which is in front of here. You don't have any numbers, so you can just make it 1. So it's positive. So our absolute value function is going to open up. All right, so what's the vertex first? The vertex is the opposite of the number next to x, which is negative 3, and the opposite of the number next to y. So the opposite of negative 1 is positive 1. All right, so there goes your vertex. So let's look for negative 3 and 1 on the graph. So we go 1, 2, 3, and then go up 1. All right, so since a is 1, positive 1, it's going to open up. All right, open upwards. And it's not going to be wider or narrower compared to your standard absolute value function. Okay, so it just opens up. And then what we're just going to do is we're going to draw our v, following the pattern of your standard absolute value function. Starting from that vertex there, negative 3, 1. That would be going in that direction. And then the other v going in the other direction like that. Okay, so there goes the graph. So you have a shift to the left 3 and up 1. All right, let's take a look at number 2. To graph this, I'm going to put the function in general form first. So we have y equals absolute value of x plus 4 minus plus 2. So I'll subtract 2 from both sides. Subtract 2, subtract 2. And then that gives you y minus 2 equals the absolute value of x plus 4. Now there's no number in front of the absolute value, so we can put a 1 there, positive 1. All right, so with this information, this tells me that the vertex is going to be negative 4, comma 2. How do I get that? You take the opposite of the number next to x, positive 4 is negative 4. And the opposite of the number next to y, negative 2, gives you positive 2. All right? This parabola, this absolute value function opens up because a is equal to positive 1. All right? So the opening is going to be upwards, open up. All right, it's not going to be wider or narrower than your standard absolute value function. All right, so let's go ahead and grab the center, the vertex first. Negative 4, 2. So you go 1, 2, 3, 4 to the left and up 1, 2. There goes your vertex. And then we're just going to draw the v following the pattern of your standard absolute value function. All right, so this goes straight through there, and the other goes straight through there like that. All right. Okay. Now, let's move on to the next question. Question number 3. We have y equals absolute value of x plus 4. So we're going to subtract 4 from both sides. Subtract 4, subtract 4. So we're going to have y minus 4 equals absolute value of x plus 4. Now this is the general formulation of this absolute value function. Alright, so your vertex is going to be, you take the opposite of the number next to the x, negative 4, your number next to the y, positive 4, and your the opening, since a is positive 1, it's going to open upwards, okay? It opens upwards because it's positive. So there's a 1 here. You can put the 1 there. Since there's no number, put a 1 there, okay? So let's go ahead and graph this vertex, negative 4 and 4. So negative 4 and go up 4. And then you're just going to graph your standard absolute value function. It's neither wider nor narrower. So it goes like this and like that. Ooh, let me fix that other line. And like that. Okay, your standard V for your absolute value function. So this is a shift to the left 4 units and up 4. Alright, let's take a look at number 4. Let's put that in general form first, and then we'll find the vertex and the opening. Okay, so to put this in general form, I'm going to add 2 to both sides. So we're going to have y plus 2 equals absolute value of x plus 3. Okay? Now with this information, I know that the vertex, we do the opposite trick again. Opposite of that is negative 3, and then opposite of that is negative 2. And then your opening, since a is 1, positive 1, it opens upwards, okay? The absolute value function opens up. So you have a 1 right here, positive 1, because there's no number. So there goes the direction of your opening. Alright? So we draw the center, negative 3, 1, 2, 3, and then down 2, 1, 2, there goes your center. And then you draw your standard absolute value curve. It's neither wider nor narrow because a is 1, which means it's identical to the parent absolute value function. Okay? So draw a line through there, like that, for the left side, and then the second side goes straight, that fashion. Alright, so there goes the answer. Alright, last but not the least, number 5. I'm going to put this function in the general formulation. So we have y equals absolute value of x plus 4. To put this in the general form, I'm going to subtract 4 from both sides. So we have y minus 4 equals the absolute value of x minus, since there's no number there, just put a 0. Okay? And you have a 1 in front of the absolute value bars for a, because there's no number there, you put the multiplicative identity, which is just 1. With that information, we know that the vertex is going to be the opposite of 0 is 0, and positive 4. And for the opening, we have a equals 1. So we know that it opens up. And it's going to be identical in width to your parent absolute value function, alright? So 0, 4 means we just go up 4 units, 1, 2, 3, 4. And then we're going to graph our standard absolute value parent function, alright? Which goes like this, slope of 1 to the left, to the right, and slope of 1 to the left, in that manner, okay? So there goes your absolute value function. Alright. Thanks so much for watching this video. Please subscribe to my channels for more updates and math practice video clips. And you can also request help in the comment section. More videos can be found on microserve.com. Thanks again and have a wonderful day.